Hello again and welcome to this webinar organized by the Nigerian Society of Engineers, Glasgow branch, Scotland, UK. It's our fourth webinar in the third series. We've been running this for 3 years non-stop and dishing out really important technical and general information helpful to our members and to all members of the NSC in general and everyone, general public, of course. We're a charity organization also here in Scotland, so this is part of achieving the objectives we have to deliver. And today we are bringing you again another very interesting session of our webinars with special guests. The guest speaker for today, Engineer Ikechukwu, already with us. He'll be talking about gas turbine fleets utilized for power generation in Nigeria. He's very experienced in this, and he'll be doing justice to this talk much later. As usual, we invite you to engage with us. These are all of our media platforms on the screen right now. Feel free to reach out to us on Twitter. Go watch our videos on YouTube. We have a whole lot of videos there. They're making numbers, and we need you to subscribe and also watch the videos and gain the knowledge that we have put out there just for free. Thanks to all the guests that have been speaking on our webinars so far. And also we have a website, so feel free to browse through our website for different information. Kindly put your microphones mute throughout the presentation, except of course you're invited to speak or invited to do so, to unmute it. And if you have any questions or inquiry of any kind, you feel free to put it in the chat option and it will be taken up from there. Right. The usual rundown would have a welcome address from the chairman of the branch, and then I would introduce the speaker's profile and he'll give the talk. And then we'll have time for question and answers and interactive sessions, and a few announcements and the vote of thanks, and then we close for today. So I'd invite the chairman, NSC Glasgow branch, Engineer Dr. Oluseun Adediran, CEng MNSC, for a welcome address.
Thank you, Dr. Emmanuel. As Dr. Emmanuel suggested, now if people can move their mic, please, that would be appreciated. And I just want us to start by saying thank you for all of anybody online now for joining us. I know, especially if you are joining from Glasgow, anywhere in Europe, this is a time where sun is shining and you still take your time even to sit down on computer to join this webinar. Many thanks for doing that. I just want to recognize in any of the NSCSCO here, and also to recognize the NSC in general, National President, Engineer Udi, TSG, FNSC. You highly recognized. I know you will have joined us, but it's in Kano as we speak. I want to recognize Engineer Professor Kafayat, Dr. Adeaga. Those are the people, the Code and Standard Committee. Dr. Adeaga has been part of us for a while, in terms of collaboration and any other things. I want to recognize all the ESCO members of the Glasgow branch. You are all highly recognized, and all our members in Glasgow branch. Please, at any time, if I have not mentioned your name and you are joining us, whether as a part of the National ESCO or a branch chairman, please do let me know, and you'll be recognized at some point later on. Without wasting too much of time, this is a critical topic, as Dr. Emmanuel mentioned earlier on. Gas turbine is anything rotating equipment, because I'm in the same business, so it's critical. And you hardly see anybody that have that knowledge. We have someone like our member engineer Ikechukwu taking his time and want to deliver this lecture. I can tell you is if we are paying him millions of pounds, maybe it will not be enough. It's a knowledge that build over the time. You can, when it comes to rotating equipment, you can't jump the queue. You need to just queue, then accumulate the knowledge, then before you can even transfer it. Thanks so much, Engineer Hike, for this, and hope that any knowledge that you share today will be able to make it to move Nigeria forward and change Nigeria for better. Thank you so much. And the most important thing, which probably you hear a lot about this during this program, is our upcoming event. I'm sure that Dr. Emmanuel will talk more about that at some point. In case you are looking forward to come to Glasgow for this summer, please, you'll hear more. Just wait till after the event so that I will tell you more about that. Without wasting too much of your time, if you are National ESCO or the chairman of the branch, please do let me know. I will recognize you at some point. But everybody joining us, we appreciate you and speak to you soon or later. Yeah, thank you. And you are all recognized. Thanks for joining us. Speak to you soon. That's all from me, Dr. Emma.
Thank you very much, able Chairman, for making us feel welcome. And thanks once again for joining us from wherever you've joined. Hope you're safe and all is going well where you are. Well, we'll move on straight into the talk. And as mentioned earlier, our speaker for today is Engineer Ikechukwu Monday. And he'll be talking on the topic gas turbine fleets utilized for power generation in Nigeria. Engineer Ikechukwu grew up in Port Harcourt. He had his childhood in Port Harcourt, Nigeria, but is currently based in Netherlands. He had a Bachelor of Engineering from the Federal University of Technology in Yola, Nigeria in 2002, and had the compulsory National Youth Service Corps and worked with Cyber Solutions as system engineer from 2004 to 2006 before moving to Dangote Group as process engineer in 2006. After that, he joined General Electric's Power Services as lead field engineer, TA, in 2006 to 2014, before moving to SULZER Gas Turbine Services as field and shop services manager, where he's been till date in the Netherlands. He's accumulated over 15 years, actually, of experience in power and energy systems. And as mentioned by the chairman, you don't get that kind of experience from anywhere easily. And so we're in for great talks today. His achievements are numerous. A few of them include that he's been involved with the installation and commissioning of multi-unit power plants in Nigeria, in Saudi Arabia, and in Ivory Coast. He's been with gas turbine maintenance and upgrades in EMEA, South America, and Russia, and in Asia. He's mentored several field engineers in MEA. He's a certified Lean Six Sigma Green Belt in 2013, a GE certified gas turbine field engineer since 1996, gas turbine condition-based maintenance inspector since 2012, and is a certified site manager for over 10 to 12 years now, and a lot more. But I'll stop here for now. I'd like to invite Engineer Ikechukwu Monday to take over now and present his talk, Gas Turbine Fleets Utilized for Power Generation in Nigeria.
Well, thank you, Dr. Emmanuel. I think I was wondering, am I the one you're introducing? Because you said it all.
I had to keep it short.
Yes, thank you everybody for joining. First, thank you for the chairman, members of the ESCO and members of the Glasgow branch for having me. I hope we'll have an interesting discourse today. So let me share my screen. Can everybody see my screen?
Yes, I can see it.
Yes,
Good.
Yes, we can.
Thank you very much. So I understood I have 45 minutes, so I'll be a bit fast, but so that at the end we'll have more discussions because this is, as we know, power is a big topic in Nigeria. Successive governments, they've come, they've tried, but this has been an existing challenge. So it will be good to hear from you. I will share my experience with what I've gained working in Nigeria and also across the world. So thank you very much. So I will go for today, our topic will be, our agenda for today is, okay, Engineer Emmanuel has already introduced me, so I will jump that. I won't talk so much about myself any longer. Then I will give a little brief background information on how power generation started in Nigeria and where we are today. Then I will focus on three main fleets that has the highest capacity in Nigeria. Then I will share some knowledge on gas turbine maintenance and also some case studies and damages that we've seen working for SULZER. So like Engineer Emmanuel said, I'm Ikechukwu Monday. I'm the Field and Shop Repair Service Manager for SULZER Turbo Services here in the Netherlands. I've been here since 2014, running the field service and repair of gas turbine components and maintenance in the field. So SULZER, like you know, is a big group. It's a Swiss company, over 100 years old. They are known for pumps. They are an OEM for manufacturing of pumps. And there are three main divisions in SULZER. You have the pump equipment, which is the core business. Then you have the service division and the Chemtech. Chemtech, they build static equipments like separators, all of that. Actually, they have a project with the Dangote refinery. But I work in the service division. There we have several branches like electromechanical, gas turbine, compressors, steam turbine. So I'm in the gas turbine business. So yes, how did power generation start in Nigeria? From research, it's clear that this has started since 1886, when two generating sets were installed in the Lagos colony. Then in 1929, the British colonial masters formed the Nigerian Electricity Supply Company, responsible for generating and transmitting electricity. And in 1951, also, an electric by act of legislature, the Electricity Corporation of Nigeria was formed. And also in 1961, the National Dam Authority also was formed. The National Dam Authority were looking after all the hydropower plants. Then the almighty NEPA was these two companies were merged as one, and that was the formation of National Electric Power Authority, known as NEPA. And this was formed in 1972. So NEPA took charge of the whole power sector of Nigeria, ranging from the generation, the transmission, and the distribution for over 20 years. And they had about 79 plants before it was dissolved. So due to the military influence in Nigeria, between 1972 to 1999, when we went back to civilian rule, especially from the 80s, a lot of investment was not put into the power sector in Nigeria. So this resulted to having dilapidated infrastructure, and also looking at the population growth of the country, Nigeria also did not really invest. So this was one of the key agenda of the new government, see how restructure this sector. So in 1999, when our then president, Olusegun Obasanjo, came in, he started looking at how that can be achieved. So in 1999, they gave the initial IPP, independent power plant licenses. So they gave to like Shell, and where they built the AFAM IPP, they gave to the AES, the badges in Lagos, and also AGI, the Obai power plants. So, and by then, the National Assembly also started looking at, okay, how can we restructure the power sector in Nigeria? So in 2004, 2005 first, the Electric Power Sector Reform Act was passed to law by the National Assembly. And this act was to restructure the whole power industry in Nigeria. I hope everybody can hear me.
Yes.
Am I very
Yes, we can
audible?
hear you. Yeah.
Yes, you are. Yeah.
Good. So as a result of that, NEPA then was unbundled to a power holding company of Nigeria. So that was one of the results that came out of this act. And if you remember, in that period, we had the oil boom due to the war in Iraq, and there were so much money generated from sales of crude by Nigeria. And this was put in a separate account. I can't recall the account. Part of it, all the Niger Delta state governors decided to form the National Integrated Power Project, NIPP, to finance it. And the plan was to build 10 new power plants in Nigeria. And this started in 2004. So 2 of those power plants were awarded to Siemens, and the rest were awarded to General Electric. And I was involved in a Harbor power plant, in installing it and commissioning it and handing over to the owners. So as a result of the act as well, the power holding company, was unbundled into a generation company called the Gencos, then the distribution companies called the DISCO, and the transmission company of Nigeria. So these 3 companies were formed. So Genco takes care of the generation, transmission was taken care of, or is still being taken care of by TCN, which is a transmission company of Nigeria, and the DISCOs, which is distribution company of Nigeria. So this was how what made up the power holding corporation. So as a result of so much investment also put into this sector, but still it did not yield much big fruit. We saw that power actually reduced from 5,600 megawatts to almost around 1,750 megawatts between that period to 2011. So the successive government that came in also started looking at, okay, what can we do to really boost this, get rid of this challenge in Nigeria? So in 2010, there was a power sector roadmap, which was enacted, which was formed. And this was a roadmap to show the privatization of the power sector. Reason being that the government has seen that, look, all these years, it has always been the government. So they tried to say, okay, it's time to really take our hands off and just be the regulator and hand over business of power to private companies. So there was a roadmap created. So as a result of this, 6 of the generation companies were sold, and also the 10 DISCOs, 10 DISCOs, that's a distribution, were also sold. And the good thing was the generation company was completely sold, but the DISCOs that were sold were subsidized. So government had some percentage in it, And as a result of that, other power generation companies started coming up. So for power generation, today we have over 23 grid-connected power plants, which has a total operating capacity of about 10,000 megawatts, of which what is available to go to the grid is about 6,000 megawatts. And out of this 10,000, about 8,000, which is about 80% of the power generated in Nigeria, it's generated via thermal power source. So in 2019, Azura came on board because between 2010 to 2019, it was all about the NIPP project. So no much new power plants were built. They were trying to complete the NIPP, which they completed. Some are still under construction today, not yet completed for obvious reasons like our country. But, and this was handed over to Niger Delta Power Holding. And there was a plan to sell this power plant, but still that hasn't happened for those GENCOs. So, but the old power plants from Nepal, like the Ughelli power plant was sold to Transcorp, the Egbin power plant was sold to Sahara, and all of that. Those were the privatization that happened with the GENCOs. So in an average today, as it looks in Nigeria, we have about 13,500 megawatts available power. What the grid could take today ranges on an average of 3,700 megawatts. So you can see that we still have a big gap there. Okay, and this, I'm just talking about grid connected. I'm not talking about private power plants that's owned by companies. Because if you go to like RG flow stations, they have a lot of power wasting because they cannot, they don't have a power purchasing contract to sell to the grid, or even the grid cannot take. So these are just grid connected power. And that is our main focus for today. So study has shown that only 57% of Nigerians or Nigerian populace is connected to the grid. So you can see that there's still a very big gap in power sector in Nigeria. And I tried to also look at, to just prove to you, I looked at the site of a National Electricity System Operator, and to just see, okay, as at yesterday, you can see that the power transmitted in Nigeria ranges from between 3,000 to 3,000 megawatts. This is out of the 13,000 megawatts available. So you see that there are several factors affecting, even if the GENCO, the generation side, has been sold and is operated by private individuals or private companies. Still, there is a big gap. And also the DISCO as well, there's still a, we'll touch this later. So just a little bit of summary, how does power get to our homes? First of all, there are several, I call it power sector value chain. So for you to see electricity in your house, it takes several things to put it together. First, you need the gas from either NGC or from independent oil operating companies. They supply gas to these thermal power plants, which are run basically by gas turbines, mostly. It's only Egbin that is a purely steam turbine. And you have the one in Papalanto, which is combined cycle. Most of them are simple cycle power plants. So then you need the generation, power generation. So here we are looking at gas turbine. So you need the gas to go into the gas turbine and fire the gas turbine, and power is generated. And when that power is generated, it needs to be transported. And that is where you see the TCN, the transmission sector. Then once TCN acts as the transport, now they have to supply this power to the DISCOs, which is the distribution company. And the distribution companies are the ones that get it to our home. So this part of the value chain in Nigeria has completely been privatized. And in my own opinion, there is no much problem in this sector. However, also the DISCO has been sold, but still there are a lot of challenges in running it because infrastructure issues, liquidity issues, and all of that. Then TCN, which is the transmission, this sector is still being managed by the government. And you can remember there was this presidential power initiative, which was signed with Siemens. Part of it was to look at how to fix our transmission sector, power transmission sector. So normally, when a power plant runs, the energy produced from the rotation, the mechanical energy is converted to electrical energy, and you run a generator and you generate. Normally, the power that gets out of the generator is about 15 to 22 kilovolts. Then you have the generator step-up transformers, which are installed here, which now steps up the power generator to 330 or 132 kV. So Nigeria has two major grades capacity. One is 330 and one is 132. So it either converts, steps up the 12.5 to any of these. And that is now transported across the whole country and supplied to the discos. So it gets to the discos, and with the transformers in the discos, it's now converted to either 33 or 11. And then it's being reduced till it gets to our home at 220 volts, which we use for running our appliances. So this is generally how the value chain of electricity goes. And for the power plants, power generation sector, our focus today will be on gas turbines. So, what is a gas turbine? It's always easy to talk about gas turbine, but what is a gas turbine? Just like any other. However, it has some great features, which makes it a very robust engine and that is used in several applications. So a gas turbine is essentially a heat engine that utilizes air from the environment that is compressed, and then there's a source of fuel that ignites to extract heat energy, and the heat energy is converted by rotating gas turbine blades and vanes to kinetic or mechanical energy. And this mechanical energy can be used for several things. You can connect it to a generator to produce electricity, or you can also use it to drive other rotating equipment. So in order to achieve this, the air passing through the engine has to be accelerated. So when you have air coming into the inlet of a gas turbine, this needs to be compressed, and there's a kinetic energy which the mass flow of the air is being compressed and it's being increased so that you can get very compressed air. So that comes into the combustion chamber, where there's a source of ignition and gas. The gas I talked about comes in then, and then the hot gas is extracted via the turbines to generate power, or to generate, if you need it for driving an equipment, or you need it for driving electricity. There are three key sections, components of a gas turbine. You have the compressor section, the turbine section, and the combustion section. So I gave some example where you use gas turbines, but I will explain more in subsequent slides. So what is the key principle of a gas turbine? For every engineering or for every technology, there's a theoretical principle on which those design is made. And for gas turbine, unlike steam turbine, which the Rankine cycle, gas turbine operates on a Brighton cycle. So George Brighton, developed this concept for internal combustion engines. So how does it work? If you look here, this is a pure gas turbine. This is the auxiliary skid of the gas turbine. So this is a compressor, this is a combustion chamber, and this is a GE frame 6 gas turbine. So this is the combustion section, and this is the turbine section. So what happens is, what this principle states that at point A to B, air comes in at ISO conditions. So maybe at humidity of say 60%, at a temperature of say 15 to 20 degrees centigrade. So the air comes in. Obviously, normally there's a filter house which makes sure that no unwanted elements or foreign objects goes into gas turbine. So the air comes in through the filter house, which is not, from there it comes to the inlet. So at the inlet, that air needs to be compressed to go for combustion. So what you see is that between point A and B, there is, first of all, the volume, the volume that comes in there is high, and the volume reduces across the compressor. Meanwhile, you need to increase the pressure. So that increases the pressure. So what you see in the design of this gas turbine, if you look at it, basically, at the starting part of the compressor, you see that the cross-sectional area is much. So you see, and this reduces. And when you reduce the cross-sectional area, what do? It reduces the volume and increases pressure. That is just the concept. So the air that comes in from the environment is being compressed, meaning that pressure is increased, and when you increase pressure, looking at the gas law, obviously you increase temperature. So then that comes to the combustion section. When it gets to the combustion section, that is between this cycle B to C. Okay, this is this point. So at this point, a source of ignition is being there will be a source of ignition. There will be gas, and there is the air, compressed air. So when you have gas, which is the fuel, it could be gas, it could be liquid, because some of these gas turbines also run with liquid. In fact, now most gas turbines, because of what is happening with gas and also the environment, most companies now are developing and looking at the technology of running gas turbines on hydrogen. So you have a source of fuel, you have a source of ignition, just like you have in your car. There's a spark plug, and you have air coming in, compressed gas, air coming in at high pressure, high temperature. What happens is there's a source of ignition. So there is combustion. So when that happens, the hot gas, which is being combusted, is being extracted with the gas on the turbine. On the turbine, you have stationary parts, which are the vanes. In some technology, they call them the nozzles. And you have the turbine blades, which are rotating. On that, and on that rate, the hot gas, the energy from the hot gas, which is heat energy, is being converted to kinetic energy. So there's an expansion because of increase in temperature, and at that point, what do? Then the work is done. So then that energy produced is now being, you can convert the energy to electrical energy by running a generator. A generator is just an equipment with a rotor rotating under magnetic field. So to generate electricity. Or like I said, you can also use that energy to drive like a bigger compressor. And finally, there's an exhaust. So the exhaust, which is the last time, the exhaust, the energy that is not being used is sent out of the through the exhaust stack as waste. However, that's why the efficiency of a gas turbine is not high, because you waste a lot of energy. So that is why most times you can convert that energy into more power by connecting a heat recovery, a HRSG, heat recovery steam generator, which convert that heat energy to steam, and you use it to run a steam turbine, and you can connect another generator to produce more power. So and that is what is known as a combined cycle. So, but my focus today will be basically on simple cycle, because 80% of the power in Nigeria is being generated on, say, simple cycle. If you have any question, you can always stop or drop it in the box. We'll take it later. So I tried to do the analysis of I'm trying to get this stuff off my screen. Okay. So I tried to look at, okay, I've been talking about gas turbines, but you have to also know how many gas turbines are grid connected and where are they located. So I looked at all the power plants in Nigeria. I did a kind of analysis on them. So we have AES, there are 9 from 6 GE gas turbines there, but these machines have now been relocated to Sapele. Then you have Transcorp Power that bought Afam Power Plant in 2020, November 2020, yes. Then you have the Azura, which I just mentioned. They have 3 Siemens V94.2. It's the newest power plant in Nigeria now. Then you have Opai, which is owned by Ajib. You have the IBOM, which is an IPP located in Akwa Ibom. It's owned by the Akwa Ibom state government. Then you have the NDPAC, the National Niger Delta Power Holdings Company. They have about 26 GE frame 9 and 6 Siemens V94.2. So total machine in their fleet is more than 50. So this is, those, I told you about those 10 power plants that was awarded the NIP project. So this is the company running that. Then you have Shell. They have 3 Aston Titan E2s. Then you have the Engr, which I've touched. They own the Sahara Group own the Engr power plant and FIPL, and also the Omoku power plant and the Transamadi, which was owned by the River State government, also to Sahara. So in total, and you have obviously the Ogeli power plant, the Delta used to be called Delta 1, Delta 2, Delta 4, which is owned by Transcorp Power. So a total of analysis I did, these are machines that should be in the grids, about 118. However, the ones marked is the ones I want to specifically look at. I will just explain how they operate, what are the differences, what are the advantages of having them, and what are the disadvantages. So one of the machines that I will look into will be the Siemens V94.2. There are 11 of them in Nigeria. And out of that 11, 9 is in operation, 2 are in Afam power plants, which are now being rehabilitated after Transcorp bought that. Then you have the GE frame 9, that is the biggest fleet. There is 33 of them, 28 is in operation. If they are operating optimally, that's another question for another day. Then you have the Aston Titan E2. There are 6 of them, and 6 of them are also in service. So these are the machines we look at. So if you look at the percentages of each, the GE frame 9E occupies about 66% of the total fleet. And then the Aston machine has about 12% and the Siemens 22%. So I'm focusing on these 3 machines because they are known as E-Tech, because they are machines that can run under 50 hertz, because the frequency of our grid is 50 hertz, and they are very robust, and they also have the highest amount in our grid. So I'm talking about grid connected. I'm not looking at the other power plants owned by other companies that are not grid connected. So the GE frame 9E, the GE frame 9E is a machine that has 17 compressor stages. I did not mention, so there are different types of compressors. You have the centrifugal, you have the axial compressor. But in gas turbines, they use the axial compressor. Every gas turbine uses axial compressor. And the reason with that, because you have multiple stages of compression. So if a gas turbine did not have multiple stages of compression, after using centrifugal compressor. But if you use a centrifugal compressor, it will be a very robust application, too big, because out of every stage to go through a process to cool and come back and all of that. So every gas turbine is operated with a at least for now with axial compressors. So the GE frame 9E has 17 stage compression, and it has 14 combustion cans. Okay, I did not, so one thing I did not mention, I told you there are 3 sections of a gas turbine. You have the compression, the combustion, and turbine. Also, in the combustion, there are several types of combustion systems. So there is the annular, there is the can and annular, and there is the silo combustion system. So we'll see how these machines have different combustion systems. So the GE run on the can annular combustion system. So you see, these are the cans where the gas comes in. This is one of the spark plugs that ignites, and the air comes in through the compressor into the combustion chamber where the combustion happens. And it has a 3-stage turbine. So this is the first stage, second stage, and the third stage turbine. Then obviously this is an exhaust, which can be connected to a stack or HRS, like I said. It's recovery steam generator. So like so you have the inlet, which is number 1. This is where the air comes in. It's being compressed in the 17-stage compressor. Then it goes to the combustion section where you have 14 cans going into the combustion chamber. So, and in the cans, you have the burner, which is called fuel nozzle, where the ignition happens, where the gas comes in. Then you have the combustion liners, which streams the hot flame. Then it goes through a transition piece, which a kind of narrows the movement of the hot air into the turbines, which now extracts that hot energy, heat energy, and under rotation that converts it to mechanical energy. So the GE gas turbine, the frame 9E, has 3 bearings. So these are standing on 3 bearings. This is bearing number 1, bearing number 2, and bearing number 3. So it's a 17-stage compressor. It has a 17-stage, 3 bearings, 14 combustion cans, 3 turbine stages. So this machine, on an average, there have been several upgrades done. On an average, it's about 120 megawatts, one of them. And as I showed you in NIPP, they have over 20, I think 20 something of them. And it has a firing temperature, because for you to also get more power, this firing temperature is the temperature at which the hot air gets into the turbine. It plays a very big charge, because the higher this temperature, the more power you can get from the gas turbine. So that is why it's very, very important to also check the condition of the air coming in of the gas turbine. So if I will explain in later stage when I talk about the different upgrades. So when they do upgrades, some customers or some countries, they need more power, or some need more efficiency, or some need, because of environmental conditions, less NOx, CO sent out to the atmosphere. So in this stage, they consider all this. So if you need more power, for instance, you will look for a way of increasing this temperature. So how can you, but if you increase this temperature, you also need to consider the material of the components used in manufacturing the gas turbine, because once it gets above 900 degrees centigrade, there is big impact. So sometimes they do some thermal barrier coating of the component. That's why you see some, if you see two blades, you see one coated with thermal barrier coating called TBC, and some are not without coating. There is a reason for that. One of the reasons is, to withstand those high temperature. And obviously, cooling is also a very important fact, because you also want to make sure that proper cooling happens. So most of the air, actually, if I'm not mistaken, the air that comes out of the compressor, I think about 30% is what is used. The rest air is used for cooling and other things, sealing, because you also don't want the hot flames or the hot gas to get to the surface of the casing. So you use the air, which they extract from the compressor, to do those kind of job. You also need the air to do some cooling in the bearings, because the bearings cannot withstand more than 120 degrees centigrade. Not the white metals, they disintegrate. So you also use those sometimes air to cool, even if you still have cooling water there. So I've explained the exhaust. Then you have the GE gas turbine. Also, there are two rotors, connected together. So this is one rotor that has the gas turbine, the turbines, and this is another rotor with the compressor. So during maintenance, you can decide to lift these two rotors as a body. That means you need a bigger crane. But if you don't have the opportunity, there's an opportunity in this coupling here to disassemble it and take the rotors piece by piece. So this is one advantage you have with this GE, which some other ones don't have. So normally this is if you leave the rotor together as one. Then the second is the V94.2, the Siemens V94.2 gas turbine, which we have about 9 of them. 11 of them, 9 in operation. So it's the Siemens V94.2. So I told you the combustion chamber of the GE is the can annular type. But for the Siemens, you see, these are the combustion section. You have the silo type combustion chamber. You see 2 combustion chamber. Here are those fuel nozzles, the burners. So the gas comes in from the top, it's being burned, it goes into the combustion chambers, the hot air is extracted through the inner casings, and then it goes to the turbine. So this is the inlet where the air comes into the compressor. Then you have for the Siemens, it's a Siemens V94.2. It's a 16-stage compressor. The GE was 17-stage, but this is 16-stage. So it's a 16-stage compressor, and you have two combustion chambers, 2 silo-type combustion chambers. You see how huge they are. Why the GE own, the American concept, is very small. Those cans, around 14 of those cans, but this you have 2 combustion chambers. So maintenance of this gas turbine is quite, everything is big, so it's a bit difficult, but somehow also easy. It has its own advantage and disadvantages. So this gas turbine, it has an average output of 166 megawatt. The GE is 120. This is about 166. So, there's also a reason for the hugeness. So you get more power out of this. But if you want easy maintenance, you think about the GE. If you want a robust machine, then that you spend so much maintaining, you think about the V90. It depends on what choice you want to. So so when for a power plant, when they're selecting the gas turbine, they put all these parameters together. What do we really want? and then they make the selection what really fits. And that's where the consultants, what they look at. So this is a typical how the combustion chamber looks. You have the burners at the top, and you have the flame tube with ties. These are ceramic ties, which protects the hot gas from getting to the casing of the combustion chamber. Then you have the mixing chamber, which in GE is called the transition piece, which I showed just a little, but this is, you see how huge, there are two of them, which more or less narrows the hot air to be able to go into the turbine. And so the hot air coming out of the inner casing, out of the mixing chamber goes into the inner casing. So here you find the inner casing, and from the inner casing it goes to the turbine. And this turbine is 4-stage turbine. So you see the more stages you have, the more output you get. So the GE it was 3-stage turbine, but the Siemens is 4-stage turbine. And what you see here is that the firing temperature of this for Siemens it's just a terminology term. GE calls it firing temperature. Siemens calls it turbine inlet temperature. It's European and American. If you also check Aston, now GE call it inlet temperature, turbine inlet temperature, but the Americans call it firing temperature. So you see from once the energy is extracted, the same concept, the leftover gas is being sent out as through the stack as waste, which also you can also add a HRSG and make it a combined cycle. Then you get more output. So you see for this gas turbine, the efficiency is just 34%. If you add a steam turbine, you get the efficiency goes up to 60-something%. So here you also need to decide, okay, which kind of gas turbine do I need? And for here, the rotor is tied by only one tie rod. So you see how the rotor looks. So you don't have provision to split it. Unlike the GE, you can split the turbine parts. You see, these are the turbines part 1, 2, 3, 4 stages. This is the inner casing. This is the 16-stage compressor. For this, you cannot split it. You have to take it as a body. So you see, the current capacity is about 60 tons. So you have to have that kind of capacity. Like the job we are doing in our farm, we have to use a mobile crane of 500 tons because there was no mobile overhead crane installed. So now you have to use a 500 ton because of the height, the angles, the maneuvering to get this rotor out. And the advantage of this rotor is that for the GE rotors, you can only change only the first stage and the last stage compressor blade. So if there's any problem with the compressor, you can only change the last stage and the first stage. And if you have anything in between those stages, then you have to ship it out of the country. For instance, there's no repair facility in Nigeria, so you have to send it to Europe or anywhere, maybe the Middle East, for it to be repaired. So you see disadvantage of that. Why for the Siemens, wow, my time is almost up, so I will be a bit fast. So why for the Siemens, you can do the maintenance, so you can distract all of the stages because it's just one tie rod holding it. In GE, it's like 6 tie rods holding it together, holding all the stages. Then this is the Aston Titan E2, which is the most robust, most efficient one, and produces more power. You see, it's about 36, the efficiency is about 36%. It's a turbine with 21-stage compressor and 5-stage turbines. And this one has the annular combustion chamber. And the rotor of this turbine is the welded rotor. So it's a welded steel, complete welded. It's not like the one for GE or Siemens where you have different discs, but this is a welded rotor. So you can only disassemble the blades. You cannot stack the rotor. It's a very rigid rotor. So there are several upgrades that have been done by different OEMs on these gas turbines. Like I said, there are reasons reasons for these upgrades are, maybe you need more power output, maybe you need more efficiency, or maybe you need because environmental, less NOx emissions and all of that. So the GE started, from 105 megawatts till the current one now, which is about 144 megawatts. So you see how every grade of the 9Es that they've upgraded, there is always a change. Either they change the material used in the design of the blades for the turbine, so that you can push more, you can increase the firing temperature to take more to get more output. Or sometimes they also do something on the compressor so that you can increase the mass flow of the air being compressed, which at the end gives you more output and more efficiency. So all of that. And what they did in the last one of the frame 9E is that the 9E.04, which is the GE Max, is that now it's 4 stages. So they added additional 4 stages. Then the Aston, they also upgraded same concept from the VAs to the MXL1, MXL2. Maybe in subsequent, some other time, I will explain, the reasons, give you the real specific reasons. And also the Siemens, they moved from version 3 to version 6. The ones in AFAM is version 4. The ones in Geregu are version 6. The Azura is version 6. And version 7, where they change the blades to D models to get more output. So you can see how also the outputs increased. Obviously, there also you can do something in the combustion chamber, because increase the firing temperature or the inlet temperature, meaning more heat in the combustion chamber. That means you also need to consider the material used in making the components of the combustion chamber. So maintenance of these gas turbines. For the GE has more series of maintenance. So they have the combustion chamber inspection, the hot gas inspection, the major inspection, and the GE machines operate. This is also another reason of upgrade. Sometimes you want to upgrade because you don't want to have more maintenance. They call it TBO, time between outages. So you can change the material so that you don't need to open your after a long period of time. For instance, or change your parts after a long period of time. So like the GE, the early stages were 32. At the end, when it runs 2,000 hours, you need to do a major inspection. Then it was increased to 48. The DLN, the ones with dry low NOx, with less emissions, you can run up to 48,000 hours before you can do a maintenance on it. And also the rotor of the GE, GE recommends at 200,000 hours, you should replace the rotor. But what Siemens and Aston does is at 100,000 hours, they do what they call lifetime extension inspection. So they inspect the rotor and increase the life of it, by doing a lot of modification or material or whatever. But you do the extent, you also do several NDTs to see, okay, what kind of damage, correct them so that it can run. But companies like SULZER does not believe in this concept. That's the difference. So SULZER can tell you that, no, you don't need to change your rotor at 200K. Send it to us. We'll do a lifetime extension of the rotor. Then you can still run your rotor for almost one more cycle. And one more cycle is another 200K. Or we tell you, based on what we see at the inspection, maybe you can run another half cycle, 100,000 hours. So the same with the Aston, but the good thing with the maintenance of the Siemens is that you don't open the machine onto your hot gas part. And this is almost at 24,000 hours. The same with the Aston, you don't open it at all normally till the major inspection. But the GE, you open it, if it's 32K machine, you open it at 8,000 hours or 12,000 hours. So this is like 1.5 years or 2 years, you have to do this. So these are some common defects noticed with these gas turbines. This is an issue. Actually, this is a site in our country. You know, this were due to poor operation. You know, dynamic combustion dynamics issue. These are combustion liners. You can see how they damage. So if you don't operate the gas turbine very well, or the grade is, you know, the grade frequency, which is always fluctuating, which is one of the major cases Nigerian power plants have, then you have this kind of issues. Then for the welded rotor, which you don't need to do any maintenance, the biggest challenge you have for the Aston machines is cracks. There are always cracks in the because it's welded. So due to thermal stress on the rotor, so you always see cracks. But you continue, for you to operate there, you continue to monitor those cracks, how they propagate. So these are some pictures of how you distract the, you know, I told you can do the Siemens rotor on site. These are some pictures how it's being distracted. Then I go to common factors affecting gas turbine operation in Nigeria. What I've seen in from experience is the grid. Is one of the biggest challenges Gencos have in their gas turbine. So Nigeria has a very unstable grid. If you look at the first slide, if you look at the frequency, the frequency of our grid is supposed to be 50 Hz. Okay, so when it's not 50 Hz, the OEM always, or the manufacturer of the gas turbine always gives plus or minus 2 Hz as a tolerance. But you see our grid going either higher than 54 or sometimes to 40. If you look at the data I showed yesterday, I saw that one was like 48.8, you know, okay, still within the can keep reducing. So what you do is, if the frequency is so low, you have a gas turbine of 120 megawatts. But because of the grid frequency, because now the grid frequency will be now controlling the gas turbine, you find out that it cannot give more than 60 or 50% of its power. So this is a very big issue. And that is why you see that I showed you in the first slide that we have about 13,000 megawatts that are available, but we can only give to the people of Nigeria less than 5,000 megawatts. So, but I think the government is looking into it based on Siemens presidential initiative. Hopefully they will do something about this, but also Nigerians need to understand that for power investment, you can see when we started the NIPP since 2004. It's still there. It's not something that any government that comes and says, I will give you power in 1 week, I will give you power in 6 years. It's not like that. It's capital intensive. It takes a long time. So another issue they have is gas supply in terms of quality, in terms of availability. Sometimes you have power plants sitting idle because the gas supplier cannot give them the right quality of gas, you know, to run their gas turbines. Obviously, maintenance is also a factor. So these hours, like I showed you for the gas turbines, there are design hours of which you have to do a kind of maintenance on it. And if you don't do it, what do? You stress the components so far, and you end up running the gas turbine to failure. And there is also, I think Nigerians, based on what GE Siemens have done, there are a lot of people in Nigerians that you know, they are knowledgeable on how to, you know, about gas turbines. Still, there's still in that industry. So this is where NSC should look at how we can build that capacity in the country. Then there are environmental factors. For instance, you know, most of the gas turbines are in the Niger Delta area. The quality of air that comes into the gas turbine has a lot of, you're like close to the sea, you know, those salty air, you know, sodium chloride, it will react with those super alloys used in the design of the compressor. So you have falling, you have issues, you have pitting, all of those kind of corrosion can happen due to those chemical reactions. And there's issue with liquidities. Like I said in the at the beginning, the Gencos have been sold completely. What happens is that Genco will generate power, they send it to the grid, and there is a company called Engr, Nigerian Bulk Electricity Trading Company. So Engr pays the Gencos, not the DISCO. DISCO does not pay direct, but now I think now they are now having PPAs between GENCO and DISCO so that DISCO can pay directly. But what happens, because the DISCOs, due to the privatizations, there is a part of their contract which is being subsidized by the government. So if, for instance, if this power plant generates like 20 megawatts and sell it, he doesn't get his money. The money comes through this national embeds. So sometimes it's also delayed, so meaning they cannot also investment and they cannot also, maintain their gas turbine. And obviously we know political influences, policies, regulations. I think NEC is the company that, or the organization responsible for regulating the power sector. We know what is happening with the electricity tariff and all of that, insecurity, corruption. So these are factors affecting proper operation and maintenance of gas turbines in Nigeria. So this is basically more, but I wanted to show you some common defects that we notice. I won't explain, I will just show pictures because of time so that I can open up for question and answer. So these are common defects you see in gas turbine operation. You have corrosion, oxidation, material degradation over time, overheating, creep. All has to also do with operations, how you run your gas turbines. This is oxidation normally happens at high temperature, above 900 degrees. So you can see, this is the type 2 corrosion. Type 2 corrosion happens above 800 degrees. You can see as a result of this, you have cracks. Type 1 corrosion below 800 degrees. These are gas turbine vanes. The stationary part, this is a blade of a GE frame 7. This is a 13 E2 burner. You can see the color, the coloration due to oxidation. And you can also see tip blade. This is a gas turbine blade. You can see tip oxidation. This is due to overheating, maybe you're overfiring. Remember we talked about, raising the firing temperature and all of that. So when you also as a result of the grid frequency going too high and the machine is not properly controlled, you can have overheating on the combustion or the turbine side. These are TBC coated frame 9E. Okay, this is 9FA blades. You can see how they are decolored. You can see they are already depleting due to overheating, because these things are designed for a certain temperature. You have creep damages, fatigue, due to thermal influence, on the gas turbine. You can have high cycle fatigue, due to the excitation of the material, especially the rotating materials, or low cycle fatigue. This is an example of what the high cycle fatigue can cause. So there was high cycle on one of the blade and it excited, and then it's liberated and caused damage the whole of this compressor. And this is a big job, and this is a GE compressor. So this compressor needs to be shipped out. At least you have to give it 4 months to 6 months before it can come back to operation. Low cycle fatigue examples. As a result of FOD, remember I told you the inlet, there's inlet filter, where sometimes if you operate your gas turbine without filtration, you can't control what goes in, and what you see is this kind of damages. But anyway, this one is a generic fact known with GE stage 3 due to the alloy. They had issues with the material. So there's a technical information letter by GE that tells you at certain hours you need to do a brodoscope inspect these blades because it's a fleet issue. But if you're operating your power plant and you're not aware of this, or you don't do it, what you get is a failure. Flaring due to contact, and yes, and that is it. So thank you very much for the time.
Thank you very much, Engineer Ikechukwu. I was going to say you should take your time for a moment there. No pressures really. This is knowledge we don't get from anywhere every day. So having it recorded as well and having you go on with it was going to be helpful for all of us. So thank you very much still.
Yes. Thank you. I tried to dilute it as fast as possible, but I think in each of these topics I mentioned, is like we can do an hour of each.
Yeah,
just
exactly.
looking at effect or looking at one machine, really. But I thank you for the time, and
exactly. No, thank you.
Questions and comments. Yes.
Yes, exactly. So we'll open the floor for questions and answers, and I'm calling on my colleague, is it Engineer Sharp or Engineer Fiver? To Engineer Sharp is on the call to manage the question and answer sessions. Let me drop my quick question first before I always don't get the opportunity. I was gonna I know you've said a whole lot of things, a whole lot of problems with the gas turbine, speaking from the research side of things, I can think of several research topics already for PhD students to work on and all that, but I'd like to hear from you specifically, what you think are like the urgent things you would push to researchers to look at related to the gas turbine operations, maintenance and problems, and also Nigerian power issues as well.
Yeah.
So maybe you take it later.
Globally now, there is big push on use of hydrogen. Because of what you can see, what is also happening in Europe with Russia. The gas prices are crazy. And the kind of gas the amount of gas you take, like I showed you, the most efficient gas turbine in the world is the GEHA. I think it's like 2 of it in the world is about 69% efficiency. So most of them are within 30 something. So this is already a big topic for research. How can you boost efficiency of this fleet of gas turbines?
Yeah, why is that one 69% efficient?
Yeah, they did a lot of improvements.
Yes,
from advanced materials, yes, and it's massive, it's huge. So that's one. The fuel, you can look at the fuel, especially hydrogen globally. I think there's funding, there are a lot for. I encourage researchers to look at this. Then, because hydrogen is it's a green fuel, green hydrogen. It's it has no environmental effect. Then in Nigeria, a lot of topics you can look at. I think first, you can look at how can the maintenance, how can we improve the maintenance and operations of our gas turbines? How can we improve, how can we have a robust gas turbine that does with our unstable grid, that can run with our unstable grid? The Siemens V94.2 is a bit okay there. It tries the best to run, but they suffer. And what you see, because of this unstable grid, affects the components. Because you go high, it's a rotating equipment. So just like your motor, when you're running your motor, when you're jacking, it goes high, it rolls. That's also how it happens with the gas turbine. So normally the grid is not supposed to, you're supposed to be controlling your gas turbine from your power plant, Say, okay, the grid should have been a settled issue, it's 50 hertz, that's the design. Okay, then you control, say I want to push 100 megawatts. Not the grid controlling your gas turbine. Your gas turbine is ready to give 100 megawatts. The grid is telling your machine you cannot
go. You can't skip that.
And then that's costly because it's affecting your material and you're using the same amount of gas. So these are some topics of.
Thank you.
I think the hydrogen is something very interesting.
Yes. Thank you very much. Hand over to
question.
Sharp. Yeah.
Okay. Sorry, let me come in somewhere. My name is Uchechi, senior engineer at Saudi Aramco, rotating equipment.
How are you?
Thank you. I'm good.
Good.
Hello. Please let's get it a little bit more organized.
Yeah. Sorry. Can Engineer Sharp step in just to moderate it? Thank you.
Yes.
Okay. Thank you very much, Chairman. Let's get it a little bit organized. I have seen some hands up on the screen already. There is Itoro Joseph's hand up, and I know Uchechi was speaking. So we'll go that way. Please, if you want to speak, Ibrahim has raised his hand also. Put up your hand through the electronic means. You'll be called to ask your question. If you don't get a time or if you prefer to type it in the chat box, please go for it. Okay. Thank you, our presenter. Now, let's take from the first hand I saw is Itoro Joseph Oyanga. Please go for it.
Thank you. Thank you very much, Engineer Sharp. Thank you, Ikechukwu. It's been a great pleasure listening to this. It's a very important, interesting topic to me. By the way, Itoro with Xylem North America. I have a question regarding delivery of gas. You made mention of one of the challenges we have in Nigeria is the fact that we have quality of gas by delivery, but I didn't hear anything about maintenance of, who takes ownership and accountability of delivering the gas from the gas suppliers to the compressor, or like the GENCOs, as you call it. Is that the gas supplier's responsibility? And if so, what are the challenges in making sure that these power transmission lines are maintained to ensure that there are no disrupted supply of quality gas to the GENCOs to operate their compressors?
Wow, lovely question. There are two sides of it. One is the political. There was, before the Goodluck Jonathan left, there was this gas to power, blah, blah, blah. And there's this reform of Nigeria petroleum industry bill. Part of this is covered there. So for the gas, it comes from the supplier. The supplier can be NGC, it can be Shell, it can be NAOC, AGIC, it can be MPDC, depending on the location. So when they design these gas turbines, the first thing you ask is, what is the gas properties of the gas you want to use? Because you cannot just put a gas turbine. When you're designing the gas turbine, all these parameters comes into play. Because you can say, okay, you need for this to operate because of the quality of the gas I'm receiving, I need the gas pressure to be at certain bars. So when you get that gas analysis, that is what is used to design this. And this comes from the supplier. But what you see, due to obvious reasons, maybe operational reasons, or I don't know, those parameters are not being met when you are running the gas turbine. That is one. So, but however, the power plant also has a gas conditioning facility, because there are several things outside the normal volumetric properties of the gas. You need it at a certain pressure, you need it at a certain temperature, you need it at a certain dryness, that's water content needs to be dry. So sometimes, depending on what they sign, the power plants also have like a second gas conditioning plant in their power plant, which also helps in at least boosting the properties. So, but there is always a contract. So whatever the contract states, that's how it works. Some contract says, I just need this quality straight to my gas turbine. Just bring it, it goes to the gas condition, it reduces, I equalize my pressure, it goes. Some say, okay, maybe I can also do some additional treatment. I get it at this, maybe semi property, and I have to finish it. So, but quality is one. The second thing is availability. Our obvious pipelines getting shut down, all of those things affect power plants. So yes, those are the challenges. Okay. I don't know if I answered your question.
So in summary, thank you, Engineer. There is a supplying group. Now let's take the two questions from Uchechi and Ibrahim together, so that we can save a little bit of time. Uchechi will go, and then immediately Ibrahim will also ask his question before presenter will respond to those two questions. Let's go in that order, please.
Okay, thank you so much, Engineer Sharp. Engineer Ike, thank you so much.
You're welcome.
I just want to shed a little light on one other topic. We have efficiency, we have availability, and we have reliability. For us in Saudi Arabia, we lack efficiency because obviously we have excess oil and gas here. So we don't care much about efficiency, but we care more about reliability, availability, and maintainability. So, looking back to Nigeria again, I think one key area for Nigeria to look into, or maybe I lost touch with the Nigerian, I was very key in the NIPP power plants. I headed a lot of the power plants from build-up, commissioning to handover. I think we can look into availability, because for the GE turbines, the 30K, we no longer run 30K in Saudi Arabia. We run 60K. We were able to do researches and double our firing hours. So we run 60K. Some plants run 70K, frame 5, frame 6, frame 7. We've been very successful in this area. So I think back home in Nigeria, instead of still getting tied to GE to shut down at 48,000 hours to perform a major inspection, maybe the guys back there, which was one of the things I recommended to one of the plant owners during my last interview with Tony Olumelu, Ughelli Power Plant, they should look into going from 48,000 to 60,000. It will be a very big boost to the company, to the economy, and nationwide availability.
Okay, thank you very much, Uche. You mentioned key facts. The problem here in Nigeria is
Ike, sorry, just for time's sake, let's take Ibrahim's question too.
Okay, good.
You can comment on both of them. Ibrahim.
Okay.
Hello,
Ibrahim,
everyone.
Hi.
It's Ibrahim here, ExxonMobil UK. Quite interesting topic. You actually touched on some very key aspects that impacting Nigeria's ability to provide the needed power. I just wanted to ask, in terms of maintenance, which you touched on, right? What are the key, if you like, strategies that we can implement to increase the mean time between overhaul? Like you said there, you focused more on the gas turbine, which is good, but I didn't really hear you talk more about the auxiliary system, because again, the system contributes to the overall reliability of the machine. So if your fuel valves, for example, are not very reliable, then they will not be able to respond to the load changes or the frequency changes, and the machine will not be able to stabilize in reaction to the load change, if you like. And that could also cause the cycling, which eventually impacts on the blades and further reduces the efficiency. So overall, as Nigeria, that's the power stations in Nigeria, carrying out maintenance, monitoring, condition-based monitoring, understanding how the machine works, its operating regime, all the bad actors, if you like, also the condition that would lead to the loss of efficiency. And obviously using that to optimize our maintenance program and come up with a strategy that would increase the life expectancy between your overhaul. Is that something that is being considered, or are we just running the machines to failure, take them out for overhaul, and again, we repeat the same cycle? Are there any continuous improvement that are being considered to increase the availability of power?
Yes, thank you. Engineer Sharp, can I take can I answer?
Yeah, yes, you can answer whichever order you prefer.
Yes, I think I will take both of them. They are more or less go together. Engineer Ibrahim, thank you very much. You really touched a very, very important part, the auxiliary. Auxiliary is a topic on its own, for sure. But I will leave that by the side and talk about maintenance. Because maintenance covers both the auxiliary and the powertrain, which is the gas turbine. Yes, I think the problem with Nigeria, like you said, we talked about time between outages. It's all about money. You have to invest, and that is why the private sector needs to really be strong. Because if an investor spends his money, he wants to recoup. However, what the Gencos are suffering is that, look, man, I have power to sell, but I cannot sell. You get the point. So, because the investor needs to recoup his funds and then look after the machine. But if you have 4 machines, you can only run 2, and the other 2 are just there, then you have a problem. However, there's a company that did it right, and that is the Azura. Azura signed a contract with the government, their PPA. For you to run a power plant, you have to have a power purchasing agreement with the government. This is like the contract. So, you know, because anyhow, power is like a national asset. Anywhere you look at, even in the UK, everywhere in the world, it's not something you say is completely out, because, you know, you can attack a nation through power and all of that. So the power purchasing agreement that Azura had to do with availability. Like that's touching Uchechi's question, availability. And those availability had, what do you call it? Had penalties. So Azura said, okay, the investor said, we will spend our money. The contract we want with you is that we'll always make our machines available. And once it's available, you must take the power. And if you don't take the power, you pay me for, you know, the total capacity. And that was signed. So now what the government does is that Azura is a new plant. That's 3V. It's about 430 something megawatts. So the government gives them priority, that every power coming for Azura gets to the grid first, so they get their money. So this kind of customer now can start thinking about, like you said, what can I do to extend my outage time, the time between outages, which Fort Oil has also done in Geregu. They had the 33K parts, which Siemens upgraded to the version 7. So the version 7 is, you get more, they got extra out of each turbine, they got about, I think, 20 megawatts additional. And the operating regime increased because they took out the first, they upgraded the first and second stage blade to the version 7. So you can move from version 4 to version 7. That means it takes you long, you have a new operating regime, you get more power, making more money, and you can run your turbine longer. So I think not that the people, I don't think it's the know-how that issue with the maintenance, Ibrahim answering your question, but the problem is the liquidity of the sector. So that is the biggest challenge. So I don't know if I was able to answer your questions correctly. Thank you.
Yeah, thank you.
Thank you very much. Now, let's put one more question, Engineer Ike. There's a question in the chat group, the two of them, but I'll read out one for now. Mm-hmm. Is it possible for a gas turbine to co-fire fuels? For example,
yes,
co-fire natural gas and biofuels?
Correct, it's possible. You can even mix so the gas turbines, most of these gas turbines are designed, it depends on what you want. It's a very flexible machine. You can make it a dual fuel. You can even make it a tri-fuel. I know when I was in GE, we were researching because for Sasso, one of their byproduct of their operations was syngas. They had a gas turbine that runs on natural gas. So we are looking at how we can make that gas turbine run on syngas. So meaning you can run on your natural gas and change to syngas when syngas is available. I don't know if they finished that before I left, but yes, you can make your gas turbine to run on multiple fuel. Actually, in dual fuel, you start the gas turbine with gas, you convert, you change to liquid fuel. Like in Saudi, like my friend in Saudi, where they have a lot of diesel. They run them on distillate, on diesel. That means you can actually change from gas to liquid and back to gas. It's possible.
Thank you very much.
You just need to modify the combustion chamber, the combustion system. That's the only one that needs the modification. But it has implication. If you run them on liquid fuel, the maintenance regime will change because now you have a quicker maintenance because the cycle, the effect of the liquid fuel on the parts is more. So you will have like so if you check the regime, if they say on gas, it runs 33K. If they do the calculation, if you're running on liquid, it is like 1.3% reduction, something like that.
Thank you. Thank you. So before we take one from Victoria, whose hand is up, there's a question from Michael Lodge there. Now, you mentioned about the frequency not being 50 hertz. So the questions will be, one, why? What is really causing the problem not having the frequency? Number two, why can't it be fixed? Or how do we, what is the quick things that can be done to address those problems?
Yes, that part is for the transmission company of Nigeria to deal with. One has to do, for me, my personal opinion, is that they need to they need to reorganize Nigerian transmission sector. The way it is, Nigerian transmission sector is operated from one place. It's centrally controlled. They should decentralize it. The East should have their own grid, the West, the North, and then there will be competition. You can, in places like America, you have several grids. You can decide as a power generator company, you can decide you want to put your power on this grid because that grid is efficient. Then you start making more money, So it is a problem with infrastructure. It's a problem political and all of that. It can be fixed, but the issue is that it's now that they're putting more investment in the transmission sector. The previous governments were all about generation and distribution. I think now, with like I mentioned, the Siemens Presidential Power Initiative, part of it, 80% of it was to work on the grid to fix this problem.
Okay, thank you. Victoria, please.
Thank you so much. Well done, engineer. Well done. Quite impressive presentation. I have two things to say. One is a comment, and the other one is a question that I will appreciate if you can clarify. Actually, gas purchase agreements has clauses there for securitization. So, and that can really help you protect your money or whatever you have done. So I really don't know if Genco, the generating companies take opportunity of that, and there is what you call take or pay, which is from the gas companies. So if you don't take that gas, you must still pay for that gas,
Yeah,
So
yes.
so that is an issue already, I was privileged to know about Naoka Jeep plants, the first gas to power plant that was in Port Harcourt, or is it Okpai also?
Okpai,
Yeah,
yes.
yeah. I was privileged to know they had securitization, which protected them. But the main problem, which you were actually really touching, is the evacuation of the power. When are we getting out of this? The problem with that evacuation limitation is it even increases your maintenance time for your engine.
Correct.
Because you keep on putting it in circulation at a time again, you shut it down.
Stop and start. It has effect.
And that brings in black startup and things like that. So all those issues, how far? Because I believe as an engineering organization, we should really impress some things on the government, honestly, because I've been hearing this issue for so long, but we know what the problems are. We know the solution. Is it that they are not listening to us? Or, like you said, what is the transmission company doing? And like you said, we really need to decentralize. Please, if there's any update on these things I've said, I will appreciate to hear from you.
Yeah, thank you. Thank you, madam. You're very much informed. I did not touch it. One thing you mentioned is the start and stop. Yes, like I mentioned 33K. If you look somewhere, I also put the number of starts and stop. So it doesn't mean it's which comes first. For instance, I think GE, after 1,000 starts and stop, you need to do a major inspection. So even if you run 7,000, which is in a year, and you've had 1,000 starts and stop, which is very easy to happen in Nigeria, then you have to do something. If not, because it has a thermal stress on the components. Okay, yes, just to answer your question, I think the biggest problem is the transmission and also the discos. Because what I know is that sometimes the transmission say, sometimes we want to give power to the discos and the discos say they cannot take. Because you can also check in your street for those people that live in Nigeria, how often we get transformer failures. That's also a very big problem. I showed you this, what do you call it? The chain, the value chain for power to get our home. Because what matters to every Nigerian is to see electricity. And they don't care, they don't want to know what is generation or all that. So these two sectors should be a key focus. Disco is more of political because they say, okay, when we were buying these power plants, government had also a responsibility, which is not met. That is political. Then transmission also say, even if we can even give power, The discos cannot even take to a certain limit. So I don't know, we just need that political, it's more of political influence than technical. Because the technical money can solve it, but you also need those political, because it's all connected. I think the gas is a bit better now. And you also talked about the security, which I explained with the Azura power plant. They had that security. If the grid takes or not take, you pay me my 443 megawatts. You know, those are the kind of, but the government also these days will not give you that PPA, because I think that was one of a lucky one for them. So do I know the solution? I don't know, but my own personal opinion is that the discos, the privatization of the discos needs to be looked at again, and then more investment on the transmission. Basically restructure the transmission, disintegrate it, decentralize it. So that, because that's what they did in the Genco. That's also what they are doing in the disco, okay? Although there is still, at a certain time, we will have independent grid, we'll have captive power, you know, renewable is coming on its own. All these things will change. But that political will needs to happen. We need somebody that is genuinely ready. Obasanjo, really, personal view, I would have preferred Obasanjo. If Obasanjo had done taught them, I think we would have gone far with the power sector. Personal opinion. He's the only guy that took it by the bull, by the horn, you know, to get it done. But since then, I've not seen any serious government after he left on the power sector. Personal opinion. Thank you.
Okay. Thank you very much. Thank you very much.
Thank you so much.
Okay. Yeah, I know there's some conversations going on in the chat room. That's very healthy and going on. I think the question on gap, where we have the gap in our electricity value chain has been answered. It's on the transmission, a little bit to do with the distribution as well. So meaning we're generating more than we can even handle at the moment. Okay, now Ibrahim, probably will give you another chance before we wrap it up. Go ahead, Ibrahim.
Yeah, thank you for another opportunity to ask a question. I think it's not related to gas turbines, but I think more related to the load versus demand issue that has been mentioned. So what exactly is the problem that we're not able to basically take up the generated capacity? Is it equipment problem? Is it the overall infrastructure? Or is it that due to population increase, we have now had more demand for electricity, and unfortunately the generation cannot cope with that? I don't think that's really the case, because from what I've been hearing, we have more generation capacity than we can actually consume. So is it the reliability of our transmission system that is not really giving us the capacity to take up what we're generating? Is that really the case? And I think it's just throwing this to the floor now.
My opinion is the case is reliability and lack of infrastructure in the transmission and distribution sector. I think if I become the president of Nigeria today, I will not build any power plant in the next 5 years. The reason is that I will tell everybody, go back to get all the power plant, all the gas turbines or whatever, all your installed capacity, I need it back. Then I will focus on the transmission and the distribution. Like I said, they need to revisit the privatization. I don't know how they will do it, but I think there are some flaws in that privatization. Government has a responsibility. The owners have a responsibility, and I don't know if they all met it. So that is one part. So then you talk about the transmission. I think the transmission issue is not the biggest issue. It can be solved. It's just a matter of investing. But the distribution side, I think it's more of political. Yeah.
Having said that, I think he was asking, even with the political problem, where does it hinge? Is it on infrastructure? The politics affecting the infrastructure to this. That means we don't have, in layman language, we don't have enough cables to run it into all the spots.
It's infrastructure. Infrastructure. Meaningful investment has not been done in the transmission sector since this new dispensation, like it's done in other sectors, especially the generation. So if we put more in the transmission, the way I think they are doing now, then it will improve. The point is that we should be able to transport. What the transmission does is just to as it's called transmit, just to transport, move the power from point A, just what the pipeline does for the gas. That is what the grid does for the power. Transmit it to the customer of the GENCO, which is the DISCO. Then the DISCO shares the power to their consumers. And that's how the whole value chain is supposed to operate normally.
Okay, just to ask, let me throw in this one. We have the system in United Kingdom where we live. We have the one in Netherlands where you are. And of course, our friend from Saudi Arabia, when it comes to the transmission and distribution, what can we not borrow a lead? Are there not things we can look at? Now we are okay with it, not so much okay, but we're a little bit relatively okay with the generation, but the distribution, this distribution, can we not copy some things we've seen working?
Yeah, we can copy, but we need to put in money. All these things cost money. Why, when in the street, they're not talking about distribution. When in the the street where I live in Nigeria, I have to contribute money to get transformer. How many people uses the transformer? There's a capacity load for that transformer. Demand, like I saw someone talk about demand versus load. There is a certain load that is supposed to be put on a transformer, but you also see how it goes. Those infrastructure needs to be in place. It will take time. But I think that's why I keep pointing out to the political will. When somebody steps the foot, like Obasanjo did for the generation, I say, look, I don't care what it's gonna take. I want it solved. That is what we need. Then you'll see it moving. Okay. But if we don't make that decision as a country, it will not change.
Thank you very much.
They know, technically they know what it takes. I'm telling you, they are knowledgeable, they know what it takes.
I've also told you, so they will be on one-to-one.
Excuse me, sorry.
I think we have our President Emeritus, I think, raising his hand.
Okay, let President Emeritus, please go ahead.
Thank you very much. First, let me appreciate. Ike, you have done very well.
Thank you, sir.
I'm very happy you have done very well.
Thank you, sir.
The presentation was very excellent, the topic very excellent, and you are on top of it. That's one. Secondly, let me also say it. This is very up where I want to come in here is, yes, the issue at the transmission line or in the power sector in Nigeria, basically, first, government at the very beginning did not see that power, they saw power as just a single block. They did not understand that power is in three different components: generation, distribution, and transmission. They didn't get that right. Assuming Obasanjo got that right at that time, he would have pursued the three, but they only told him power. And when you generate, you are done and dry, you just push everywhere. They didn't get that right. That's why, of course, it's still okay. At least now I can tell you authoritatively that there is more than 12 megawatt, right? Domicile in the country generated.
12,000 megawatts.
12,000 megawatt generated in the country, but they cannot be evacuated because the transmission line cannot carry.
Correct.
And I also agree. Over the years, there were very little investment in infrastructure. Very little. And at the same time, I want to appreciate this government because when they came in, they have done a lot. And I also want to answer, I'm very happy I saw Victoria here. You have quoted me with Victoria Afamuje. She is my boss somewhere. She has run away, but I saw her in my branch now. Very good, Victoria. Stay. I will link up.
Good evening, sir. I salute you.
Thank you, Ma. So, and it is also very excellent. We should also appreciate that. Why I'm saying some of these things is because I am a member of PPI. And I was appointed by President Buhari. Of course, a lot has gone in. Initially, only thinking was generation. But of recent, a lot has been done in transmission. And as you rightly said, it has to be decentralized. That is key. They have to be unbundled. Let me use this word, unbundled. It just has to happen. You may like it, you may not like it, but we are engineers and we need to say it the way it is so that people at the other end, if they want to listen, so be it. If they don't want to listen, it's on record that we have said it. TCN has to be unbundled. Regionally, I don't know, regionally, set-wise, whatever, but it just has to be unbundled. And government alone cannot continue to invest in infrastructure in that sector. Private sector must come in. Now the question is, which private sector is strong enough to come in? Which private sector in Nigeria is strong enough to come in? Tell me a bank in Nigeria that can give you $100 million. Tell me a bank. If they give you, they are collapsed. Leave all this English they are saying, we are capitalized, we are this, we are that. Give me a bank. Give that bank. That can give me $100 million or pounds, and that bank will remain. It will never happen. There's not a bank. They will just do you, give you some part, you go and marry new wife, buy a new car, and then we continue from there. So all this is private sector must come in. Private sectors cannot come in without any defined incentive because they are money driven. They need to know how they recover their money in stages, timely. Nobody is ready to fall into this Nigeria. I know you. Nobody is ready to fall into that trap. If it must happen, it must happen systematically. And people must know at point A, this is my milestone, this is the money I'm going to make, this money I'm going to recover to the company I brought their money from, and this will be my own part, my own share. That has to be established and very clearly. No ambiguity. I don't need to go to enforce anything. It has to be very clear. I don't want to talk too much, but
thank you, sir.
Thank you.
I appreciate for your time so that other people can also talk. I appreciate you most sincerely. Keep these lessons. Let it just continue offline. It has to continue. Glasgow, you must open up. Leave this chat line. People should be pushing. Let this discussion continue. People that must listen. Certainly, some of them will listen. Victoria is there. She will take it to where she will take it to. Ike is there. He will take it to where he has to take it to. He cannot just come here and then start giving us English and go back to his house and sleep. Ike, take you to the next level.
Mr. President, just to inform you that Ike is the chairman of our power committee in the branch.
Let him take it to the next level. So, yes. So before Sharon will accuse me, before Sharon and Ike will accuse me, while my concern is let him take it to the next level.
I'm already doing it. We are working with transport to bring AFAM back online.
My president.
We are working together.
My president, should I say that you are very close to presidency than us? I believe you can take it to, to presidency quickly.
Sharon, I am in Sokoto talking to you now. I came to Sokoto yesterday.
Yes, which is good, but we know that, but as you said, we don't want this discussion to just stop here. And the only thing where we can get something out of this kind of webinar, the discussion is for us to see the change in the system. And look at the power committee set up by NSA during your own tenure. That was very effective one. So I would have thought that at this stage, the report put together by that committee and all that government should start doing something. And you yourself, you mentioned that sometimes ago that a lot of people in that committee, whether they are lawyers and all that, they don't even know anything about the distributions.
Yeah.
Is it not the time for us to take this seriously and take it to another level with government and say to them, this is the time of change, you know? So you are here now. We hope that you can take this to another level. We don't mind to give you a quick summary or report and publish it in newspaper here and there. That would be nice. But
you know, I have to be loyal to my
something?
president. I have to be loyal to my president. We'll take the copy to my president. Energy president is on ground. So all of us will, where we have opportunities, we'll talk to powers that be. But the best point, our best bet is, let's take it up to energy president. We'll also be briefing him. You'll be attending meetings, and wherever we go, we'll drop the hints. I'm very happy here. We are dropping it here. And anywhere I go and have issues like this, I will chip in. I will chip in. And people who want to hear will hear. People who want to act will act. So we appreciate that. But sincerely speaking, in Nigeria, sometimes we have issues and we have problems. The man in charge as MD of the power company is not an engineer. Come to think of it.
So that's a problem to start with.
In charge of the power company, FGM power company, is not an engineer.
That's an error.
It's an error. Whether you like it, somebody might say, we engineers, we hate him. But the bottom line is, if you're not an engineer, you can never do engineering work. Simple. Simple. Yeah. I don't have issue. You are knowledgeable. I don't have issue with that. I've never argued that. But you cannot do engineering work. But in Nigeria, people always look things from different angles. They know Mr. A, they know Mr. B, is in-law to Mr. A, is a B. So sometimes these are the issues. But it's our prayers. That's why we are all there. That's why we have a president. We keep on pushing. We will keep on pushing until they do the right thing. We should not get tired. We should not get tired. It's our country. It belongs to all of us.
Yeah.
So we keep on telling them until we got the right thing. Thank you very much.
Thank you, Mr. Thank you, sir.
Mr. President. Thank you, sir. We can feel your heartbeat, sir, on this subject matter. Thank you. Let's just take the last comment before I pass over to Emmanuel, Victoria. So
I want to appreciate Alhaji Babagana, my president. Thank you. God bless you. Well done. Just to drop this, it's not only power sector we have this issue, and we have an idea, we know what to do. My challenge is this: is there no way government can let us into things that are like this in the country? Power issue, how can the NSC come in? What are the advices? Not only power now, I'm saying generally in the country, you know, medical association, what can they do? We have proposals. Many of us are doing well outside Nigeria, all over the world. But it's so unfortunate that you have these ideas, you can't even sell, nobody to buy it from you. I don't know how we can do this. I'm saying it, and I appreciate it that my brother Alhaji Babagana is here. We need to make that effort, and thank God he's close to the presidency now. Whether we need to lobby in the National Assembly or something, these critical issues need to be run through our organizations. There are so many Nigerians that can help the country. We don't even have to be president in the presidency, but committee can be instituted in each of the societies and provide solutions to problems. God will help us. I'm just putting this down, please. God will help us. Thank you.
Thank you very much.
Thank you very much.
Yeah, I'll pass over.
Hello, moderator.
Yeah.
Sorry, hello, moderator.
Yes.
I'm so sorry I couldn't raise up my hand because I'm on wheels, I'm driving. But the last point raised by Victoria actually, brought me out of the shell. Now, the main issue, when the president was talking about engineers getting involved, and Victoria too supported. Now, we have been so much engulfed in cards and calculations. Engineers need to come out right now and join that policy-making train. We need to be more political. We have left politics for them, and they play it. So just like my chairman, the president just said, let us move out now of only mathematics and simulation and design. Let's leave CAD. We know much about CAD. Let us go and use that CAD knowledge and influence the economy of the country. Don't let us leave policy making, policy generation, and policy implementation. Don't let us leave it to them. There's no way they can do it the way we want to do it. So thank you very much. I'm so sorry I didn't signify because I've been on wheel.
What's your name? Sorry.
So sorry.
Could you introduce yourself?
Let me just chip in here before I rule out. Being in politics not necessarily mean you need to go and contest. No. You can support the candidates. Finance them, please. Just finance them and stay at the background. Simple. Doesn't require you be a fiscal member of any party. No, just identify good guys and finance them. Give them support. Then when it comes to something like appointment, they'll look at us and then we'll not affect the changes. Simple. But those of us who have guts, who have very strong levers, can go into politics. And we wish them well.
Amen.
Thank you very much.
Engineer Sharp, I see one Sunday's hand has been up since.
Sunday's hand has been up, yes.
So maybe
let's take a comment, and that will be the final one, the last one
Yes.
from Sunday. Yeah.
Hi, thanks for that presentation.
Welcome.
I don't know, when it comes to power, when it comes to electricity power, to me, it's still a surprise to me to date that we're still talking about power generation and transmission in Nigeria. To me, it's just a joke, because the truth about the whole thing is, look, we're all just talking, we all know the problem. There's politics. All this thing we're just talking is just a waste of time. There's politics of those importing generators into that country. And there are those who are against the whole system. When we talk about generating power, look, you did presentation, you know this yourself. Morocco, look, just go to Marrakesh, go to Morocco. For goodness sake, just go to Morocco. Nobody talks about that. Nobody talks about that when it comes to power.
Egypt as well.
Yeah, look at Egypt, just countries that are very close by. Nobody talks about that. So the issue is, look, even when you're talking about private sector coming in, do we have an enabling environment for private sector's investment? Look, when it comes to power, whether we like it or not, you need foreign investment. And what is the enabling environment we have in that country? In every sector, most of our enabling environment, you guys know this. For a fact, you know this yourself. You're in the gas turbine. Our enabling environment is nonsense. And most foreign investment will not come in. I was once in a small country called Belize. You'll be shocked. Belize is a very small country, very close to Mexico. It's so small. And they are mostly, it's poor by nature, but electricity is not an issue. I was with a farmer who generates his own electricity himself. He had turbine. When I say he has turbine, he has this mini turbine in a well that rotates.
Mini hydro.
Yeah.
Micro.
So there has to be decentralization, whether we like it or not. Our electricity, decentralization on power, decentralization in transmission, we just have to. If we don't do this, we'll only be going around the cycle. We'll just be going around the cycle. We know where the issues are until we start closing it in, and we know that we need foreign investment. Look, you need, whether you this one, you cannot run away from that. You need foreign investment, but you have to create that environment. You don't create that environment, there will be issues. So we need to tell ourselves the truth. We need that. Yeah, thank you.
Thank you very much.
Thank you very much. I think this is to wrap it up and then pass over to Emmanuel. And our presenter today has done very good justice to that. He started by the historical background of electricity generation in Nigeria. He went through that. He demonstrated he has a very strong background knowledge and information of what is going on in the country in terms of power generation, and did very good justice to the topic. He told us where things are, how things are being run, and then he also went into the technical details, explaining the core topic we had today, gas turbine and power generation, and took us through that technical area, and then looked at, finally, at the factors affecting the problem we are experiencing in Nigeria. So let's celebrate what we have. Let's celebrate the technical expert we have today. And with that, I hand over to Dr. Emmanuel to carry on with it.
Thank you very much, Engineer Shao. I mean, just with that apt conclusion right now, I'm beginning to think we might have to upload this video in 2 sessions, the talk and then the discussions, because those are very big areas to look at. And probably we'll share these discussions around social media and see how far we get with it, because we've actually made very, very key and fundamental points here. And thank you so much again, Engineer Ikechukwu, for starting this up. And for everyone who's contributed, this has been very electrifying. Thanks so much for your contributions. I just want to invite the technical secretary of the NSC Glasgow branch to talk about the Glasgow branch power committee, which the speaker today is actually the chairman of the committee, but I'm going to allow him to rest and allow the technical secretary to just speak briefly about the NSC Glasgow Power Committee, and the need for some of you who have made good contributions here to also join that committee and join forces with what we're doing there. Engineer Favor.
Thank you. Thank you.
1.5 minutes.
Yes, I won't even take up to that. I think you've already said it all. We have several subcommittees, one of which is the Power Subcommittee. And as you can see today, it was our very own chairman of the subcommittee that gave us an insight into some of his experience. And so please feel free to drop the branch an email if you are interested in joining any, not just the Power Subcommittee, any of our subcommittees. Would leave the branch email address here so that you can indicate interest. Because these subcommittees are what we are trying to use to help contribute to the various sectors across or in the country. So yeah, thank you, Dr. Emmanuel. Yeah, back to you.
Thank you very much. That was apt. And do please put the email address in the chat box, and we will be expecting messages from people. I would move on now to share my screen. I think we have an important announcement. Right. So the chairman, in his welcome address earlier, highlighted this point, and I'll be emphasizing it again. And you're very free to wait behind after we close to talk more about anything relating to this. And this is talking about the NSC Glasgow branch engineering convention 2022. It's the first time this has been organized, and we want to make it really big and impactful. The date is 28th of July to 30th of July 2022. And it will be held here in Scotland, in Paisley, Glasgow, at the University of the West of Scotland. The theme is the role of diaspora professionals in local capacity development. Ties it to literally everything we are doing and everything we continue to do from the diaspora. And so much details are available on the website. And I just did this little demo here to show how you can get that. Just Google, is that working? Yeah. nscglasgow.org.uk. That's the web address. And straight up, you'll see that menu there covering everything about the convention. The details, we're partnering with the University of the West of Scotland. It's happening from 28th to 30th of July, as I said, and that's the theme. And every detail of the overview, the venue, how to register, how to get visa and arrange for accommodation. We're still calling for sponsorships, so feel free to contact us. And registration is already open. Feel free to explore, get the early bird discount as early as possible before it gets really crowded. And all the other details are there. So just go straight to our website and you have all the details. Flyers will be flying around very soon, lots of them. And we have lots of people coming in to join us already who have confirmed attendance. So we're looking forward to having you there. Other announcements, one more is just about this presentation. So there's so many calls for the presentation to be emailed to lots of people. Just to say that we're going to upload the video on our YouTube page, and I'll put the link to our YouTube page in the chat right now. Feel free to go there and just subscribe. Once you click the subscribe button, once the video is uploaded, you'll be notified and you can watch. And we have lots of videos there, and you can watch all of them. And also another thing we're doing differently, the committee has decided from this talk, we'll be uploading the presentation itself, the slides, on the YouTube channel there. So where you see the video, you'd see the slides just there, you see a link to click, and then you can download the presentation, straightforward. So you don't need it being emailed to you and all of that. And we'll see if we can do that for all the other talks available. So interact very well with our YouTube channel. It's very rich content there, and you'll be really glad you did. Chairman, any other announcement from, or we move on straight to appreciation and closing? Okay, I guess the silence is no. So I'll just call on the secretary of the branch.
It's okay, yeah. I think you can. I just want to just a second, Dr. Emmanuel, just to emphasize on the convention, the NSA Glasgow Engineering Convention. Please, if you have interest, as it has been indicated and showed the website, please go to the website to register. The earlier, the better for accommodation, every other arrangement, please. And if you really, we are looking forward to see everyone here. So I will say, but please, on that note, I always also want to mention the engineer Babagana. Are you still there? My IPP. Oh, I think he's offline now. So yeah, so I wanted to, he will be in Glasgow as well with other crew. So he will be joining us in Glasgow in end of July as well. So thanks, Dr. Ima. I think the key thing for us now is this convention. We want everybody to be here. We want to see what we can get out of that convention to make sure that, you know, we change the system, and we can't continue like that. Everything we've discussed today, and the action needs to start from somewhere. Thank you.
Thank you very much. And now I invite the Secretary General of the branch, Engineer Charles Okafor, to present appreciations, and then we declare the meeting closed. Engineer Charles.
Thank you very much, Dr. Emmanuel. And once again, thank you everybody for making our time to come here. I want to especially thank our able engineer Monday for making our time to give us this information, just as it is today. It's an area that everybody knows that we are struggling in Nigeria, and I want to thank each and every one of us for this brainstorming ideas, information, and then reaction. And obviously, again, to thank our able president, Engineer Babagana, for making our time to be with us. I want to let us know that that man has actually been working tirelessly. He is one of the people appointed under the 5-man power vehicle by President Buhari, to look into the power. And I want to let us know that our branch was working solidly within the National Power Committee to get some things out. And part of the recommendation of the work we did, obviously, the fruit is there today, because most of the things that was recommended has actually been set into motion, which is like this beginning of the decentralization. Let every state begins to look into their own power. So things are in motion, and I know we'll definitely get there. It's not going to be straightforward, and when we get there, the only bad news I want us to take away is that there has been infrastructural deficit for over 25 or 30 years that needs to be closed up, and that will require money and a lot of planning. That is why most of the issue appears to be there, but that is different anyway. So I want to thank each and every one of us, and we look forward maybe to having us sitting back again in an interactive times like this. Thank you very much. Over to you.
Thank you. Thank you. Thank you so much. That was really apt. And yes, the convention is an opportunity to sit back and have those kind of deliberations. Everything leads to that point, actually. And as I'll just conclude on the notes of the final comments Engineer Babagana gave about, no, I think someone else talked about as well, about getting into policy and management and all that for engineers. I think there are lots of engineers with qualifications in management. The speaker today has an MBA, for instance. And there are also people who are doing things in policy. We just need to make them more visible to the political space so that they can get into key positions, not even contesting elections per se, but, taking charge of, like putting the right pegs in the right holes, as it were, to deliver what we need. And with that, I thank you all on behalf of the branch for joining us today. And I really, really hope that you enjoyed every bit of it. Video of this recording will be uploaded to our YouTube channel. And I think we'll do that in 2 sessions to have the interactions, then the talk, because they're both very weighty today. And you can access them easily. And the presentation and the slides will also be there at the YouTube channel, which I've just shared the link to that. And again, all of our outlets, platforms here for interactions, feel free to engage with us. Thank you so much and have a wonderful rest of the day, wherever you are. Thank you.